Still says you have the markdown.
Oh,
Okay.
we'll try a couple things. We're gonna do it. I was gonna do real quick and a bit real quick in a moment. But talk about it first. So the last couple lectures were lots of talking things, and talking is not as much fun as doing stuff, right? So I wanted to do something, sort of follow along an example with something that will be very, very useful for you all. We're talking about software this week. That's the instructions that we feed into a machine. Typically, when we say software, we're thinking about lots of instructions saved in a text file that we then turn into machine language that the machine can run. But it can also apply to one instruction at a time, such as what we do in a terminal. There's lots of terminals. Technically, terminal emulator. The name comes from way back in the day when the machines were, the monitor was not really connected to the CPU. Like my dad's twin sister in 1965, she joined the Marine Corps, and they put her in one of the computers, and there was a red light, a yellow light, and a green light, and a printer. But she still had a small keyboard with a little bitty screen on it to give input. That was a real terminal. Direct access to that machine when there wasn't necessarily input output like what we think of it today. It gave her that keyboard to input, and then those three lights was the in out she had to work with. So the name stuck around. That was a terminal. It was just an extra machine networked to the actual computer. That keyboard was not necessary at all, really. Any type of input, there are lots of types of input that could have worked. Maybe not so many in 1965, but there were more than just keyboards then. So whenever screens did basically become included in every machine, they didn't have a good name for that. So they just referred to that old terminal, which was actually a keyboard networked to the computer. We're talking about networks next week. But I think everybody in modern America knows what the word network means, at least has a rough idea about it. So terminal emulators, or usually we just call them terminals anymore, are where we feed in the line-by-line instructions on our computers. And that's actually what runs the computer. So on a modern machine, like if I share my screen real quick, there's lots of places to click. All these places to click. So I have this little custom application I keep modifying over the years. It has all the shortcuts on buttons. Sometimes there's a browser here, so I don't have all the extra functionality that I don't need from the regular browsers, and just strip things down. Right now there's like a to-do list, a checklist, but it keeps altering things. But I clicked here to open that. But all of these spots that we have to click down here in the start menu, go in and search through the apps and click on stuff, the way we're used to doing things, that's all an extra layer put on top of what the computer actually knows. What that does, whenever we click on something, that just runs an instruction. In particular, it runs one of the instructions that we would type into a terminal emulator automatically in the background. So if you know those instructions, it can be quicker to type them. If we just look at our machines, everybody in the classroom right now has a laptop in front of them. Our little mouse pad has 2 buttons, whereas the keyboard's going to have somewhere between 80 and 116 buttons. Obviously, we have way more control with the 180 to 116 buttons than the 2 buttons, but it takes a while to learn all that stuff. So instead of using the mouse everywhere, which is kind of slow and at times clumsy, and at some point we're going to talk about ergonomics, it's actually bad for our bodies. The shape that a mouse comes in was never actually planned. It was never intended to be the lasting shape, but nobody ever changed it from that square box. There's alternative ones out there, but we'll talk about that sometime soon. Same thing with a keyboard. It's actually bad for our bodies, but it's what we have to work with right now. So if we know those instructions, we can type them in the terminal and just do that, have direct control over their operating system. Another thing that a lot of people don't know is that not all of the instructions that we can type in the terminal have shortcuts on the GUI. GUI is graphical user interface, or GUI. Whenever we can pronounce the acronyms, we usually go ahead and do so, because there would be so many just letters. So if there seems like enough vowels, or if you can pretend like there's vowels in that acronym to actually make it a word, the standard is to go ahead and pronounce it instead of rattle off the letters. With the GUI, the graphical user interface, not all of our instructions made it to the GUI, because certain things we want to make sure and reserve those for computer experts. We don't want people that are not computer experts entering that instruction. So there's more we can do on the computer with the terminal as well. And there's lots of them. It used to be very, very specific to the machine. And not only that, most of the ones used, so what eventually became Windows command prompt, it started as something different, as well as the common shells that we would see for a Linux or a Mac system. Bash, which was born again shell terminal. So it was like several updates along the way, but the language it took was still the same one created in the early 1970s for Unix. It's also Zeesh. Mac, Apple used Bash for years, but then decided to upgrade to Zeesh. And they're generally the same until you get to a fairly high level. So if you know Bash, you know pretty much everything in Zeesh until you get to a really high level. I guess the exception that would show up early is the concatenate command. You type right in the terminal. When you type CAD, it turns your terminal into a text editor instead of having to do one word at a time. Otherwise, it's pretty high level before you find the high level and all in the background before you get across the difference between Bash and Zeesh. Alternatives, they're cousin things. So if you know one, you pretty much know the other. But again, it was a language created in the early to mid 1970s. Same thing with what eventually became Windows command prompt. And back then, RAM was a very precious commodity. And we certainly didn't want to waste RAM on computer experts. So all of those instructions are abbreviated. That was fairly early in computing, so that there was lots of different alternatives at the time on how the syntax would go together. And over the decades since then, all the languages we still use have kind of coalesced into the syntax that's most natural for humans, the syntax that works better for us. So there were syntax improvements just because of more and more programmers coming along and making adjustments for what they preferred. And then if they did something that lots of people liked, it spread outward. And eventually there kind of became this thing that sort of consistencies between languages. So today in the modern world, you're going to study programming and start asking about languages, most people will tell you, well, just learn one really, really well. And then all you have to do is look up the syntax changes for the others, because there's a lot of consistencies. But our terminals that all use languages from before then were using the old syntax. Everything was abbreviated, so you had to remember what it did, and the abbreviation that somebody else made up. And naming wasn't consistent back then either. So just knowing what it did, and it was a lot of pure memorization. There wasn't much intuition with it. And eventually, early in the new millennium, so the discussion popped up in the late 1990s. But people knew it was time for a modern operating system control language. I'll refer to it that way. So obviously everybody starts working on one, and everybody's heard of the company Microsoft, right? I see head nods and snickers, because yes, at times they can be an incredibly aggravating company. So many things, it's just like, why would they decide to do this? And they're Microsoft, so we don't have an alternative but to go along with it, because somebody at Microsoft decided it. But every once in a while, Microsoft does stuff good. And the stuff they do well, is just off the charts, amazingly great. And their version of a modern scripting language for operating system control language and terminal was one of those things. It was so good that Mac and Linux just scrapped their plans to make their own modern language. Because I had plans in the works, but they were just like, okay, what we're planning on making isn't going to be nearly as good as PowerShell. So, because theirs was also going to abandon the old language. Windows really just upgraded their old language, so the old commands still worked. But then they grabbed the bash commands too. So the old bash language is there as well. So the old languages are there, and a new scripting language, and we can mix and match them. There's some other big changes for those who have had a little bit of programming. The old terminals, because when they started, they only returned strings, which is the technical term short for string of characters, or what normal people call words, when we put a bunch of symbols together to represent the language we speak. They would only return strings, and then we could do things with those strings, but with PowerShell, it's purely object-oriented. It only returns objects. And there's sort of a built-in thing so that it'll kick out a string so that a human can read the words that represent that object. But it's very, very different as far as we handle that, as far as what we do with that for the next instructions and stuff. So they developed a really nice one, and it is cross-platform. It works on every system. So I wanted to have a doing something tonight, look at a useful skill. If we go through PowerShell, that's one that's going to work on everybody's computer. We'll take a moment and make sure it's installed on everybody's machine, and then just have a follow along example for something that will be incredibly useful for you, no matter which direction in IT you're heading specifically. Network infrastructure people, you're going to spend a whole lot of time at a terminal. Software developers, you make the software, but then you need to run it, and that involves terminal instructions, and you don't want to trust your end user to type those terminal instructions correctly, so you usually go ahead and prepare those in advance, make sure everything's there. Cybersecurity people, you're going to be all over the terminal and back and forth, the terminal and the news, and it's going to show up, but everybody's going to use terminals to some extent. Server administrators, like network infrastructure, you're going to spend all day on the terminal because that's how we access a server. Maybe remote desktop if there's a good reason to, but most people just do secure shell and tie their terminals together. So I wanted to walk through PowerShell and look at some of the stuff there. A couple of the old commands, because some of them are really, really easy and easier than the new version. Because another thing they did is RAM was not a precious commodity in the early 2000s when Microsoft made PowerShell. So they fully spelled words out, which kind of makes it a little bit easier. We don't have to remember how to abbreviate it. We just need to remember what we want to do. And they followed very strict naming conventions so that if we know the naming conventions, we know large parts of the instruction very, very quick. Obviously we don't have time to go over everything tonight, but this week's about software, and the last 2 days we're talking, so I wanted to have a doing something thing tonight. So follow along, and let's kind of walk through PowerShell and learn some of the basics of that. So I'll share my screen. So on your computer, if you're on a Windows machine, you should be able to just search for PowerShell. Or a nice quick way to do it, if you push the Windows key and X, that gets all of your control software. So Windows X pulls up your control software. You might see terminal here. This is another thing when Microsoft did just amazingly over the top great job at the new Windows terminal. I don't have it fully configured, but if I can come over here and open PowerShell and a Linux virtual machine, a couple Linux virtual machines, and connect to a cloud server. Well, nothing's pre-programmed, but connect to the cloud server all at once. And it doesn't have to be different tabs. I didn't do it after the last factory reset because I didn't think I was going to need it this semester. But I usually keep it set up so that when I push Control-Shift-6, PowerShell and then 2 Linux virtual machines start in the same tab. Fully customizable. There's some really, really good things in there, but that's the application running the terminal. A really, really nice one you might want to look into Windows PowerShell. If you're on a Linux machine, you should be able to just install it. So sudo apt install PowerShell.
Yeah, that's how I got mine on here.
Did it work for you?
Yeah, though I had to install dependencies before I did that.
Okay, since I'm on Windows subsystem, it probably just pulled the dependencies from there.
So
But yeah, so just one instruction to do it, and then to run that PWSH. Oh wait, I have to restart the terminal. So exit to close this one down, and then I'll restart that.
no, it's the PWSH. I don't think your install worked.
I don't think it did either. Let me jump over to Kali.
I mean, I think Mint is running off the same kernel as Ubuntu is.
Sudo apt install PowerShell. I usually do that in Kali. Okay, yeah, it's definitely downloading things now.
Since Callie would be able to do it.
Yes, yeah, usually Kali comes with it, except for on mine, I deleted the one that came with Kali so that I could, because I know how to put it back in there really nice myself. And if I type PWSH, you'll see the terminal changed, and now it's a PowerShell terminal. Some things with scripting too, might as well put that on here. And then so if you're on a Linux machine, you can just install PowerShell and do it the same way. If you're on a Mac, you just use brew, so install PowerShell on a Mac. Basically the same thing I just showed, only it's brew is your installer on a Mac. Yeah, Linux and Mac, Linux and Apple both just abandoned their things. Yeah, there's even a copy button. There's a put it on a Mac, just Google that, go to the Microsoft results, hit the copy button, and paste that in your terminal, and then you can run your Mac on PowerShell. And it doesn't replace the one you have; it just adds one more option on there, right? Kind of like the software we're used to. Document editors. We can have more than one document editor on our computer. Same thing with terminals. Lots of useful things. There's some old commands that work. So everybody wants to get that installed for long. One common old command was CD, which this one often trips people up with the question. The question, what does CD stand for?
I know what it does. I don't know what it stands for.
Yeah, I don't know what it means, but.
You know what it does.
Yeah.
So on a Linux, it means change directory, which is basically what it does. On a Windows machine, it means current directory. It's a variable on Windows. So it's the same as PWD on Linux. And we reset the value of that variable, and then the software thinks that we are currently in a different directory, so it immediately changes. Whereas on Linux, it's not a variable, it's a function that actually carries out the action to change the directory. So it means different things on different systems, but the same abbreviation. So things like that would get very confusing because different people made those at different times. They would choose the acronyms. So one of the things they did with PowerShell was stop abbreviating things. And the new one is set location. So like I have a working directory, so I want to set location. I'm going to start where I'm currently at and then go into the documents folder and the delete folder. That's where I always do the working stuff. So set location is the new version of CD. So location is where we're working at. It's actually something when we're doing that stuff, it's generally often referred to as task-oriented programming. It is most often an automated process because it's very tedious, very predictable. It doesn't take a whole lot of thought to set it up. If if we're doing things in live time, it takes a lot of thought. But like if we're doing that to open a piece of software so that a user doesn't have to come in here and type all the instructions manually, it's very, very predictable, and it's a perfect thing for a computer to generate. It doesn't take a lot of thought, so a computer can generate the process. But very tedious, very repetitive. It's like task oriented. So it's go to a certain location and carry out an objective. So change directory, make a new file. Change directory, alter an existing file. Very tedious, very repetitive. But there is a lot of that in computers. And to show the naming conventions, you can say get location in PowerShell. And do you notice sort of a naming convention there? Set location, get location, those keywords that we had on there. New location, no, new location wouldn't work. That might cause problems. There's a better way to do that, but there's some keywords. Location is the thing we're talking about, and then we use very specific keywords. Another example for the host. So get host. So host is this console that I'm working on right now. And this, let me show you some of the difference. So the old ones would spit out text and it would give us all that information. Oh, let me zoom in. Sorry. Can you see that better?
My version is like, yours is 5.1, mine is 7.3.
There's different ones. There's lots of them out there. So,
But everything else matches.
I don't know why I'm on 5.1.
It's like that too.
What?
5.1.
Okay, maybe they roll back for Windows 11.
Maybe. 7.3.4.
Okay, yeah, there's lots of versions, so they could have been like 5 is the win. I haven't looked at the numbers closely, but maybe 5. It could be something like 5 is Windows, 6 is Mac, and 7 is Linux. So, but the general things we're going to see today should all apply as well.
Yeah, all the settings match.
Yeah.
It's just the version.
But the old ones would just give us those words on the screen, and we could read them, retype them, do stuff with them. But with PowerShell, let me add another word in, clear host. So notice host is the terminal we're talking about. We do stuff with it. We can store it in variables, and our variables, a variable is a named location in memory. So I'm going to say, I'm just going to call it H. We're going to delete this one in a second. And that's going to be get host. So instead of just spitting that back out, I'll stick it in a variable. And let me draw a quick picture on the board. I'm just introducing software tonight. So $H, the $sign is because it's a loosely typed language. We talked about data types some last week, right? At least very briefly. Then with strings and integers aren't the same thing. With loosely typed languages, we no longer have to worry about type. There's only one data type in the language. We can always spot those because they start with an H. A really nice thing about, I'm trying to get ahead of myself. Let me draw a picture here about what a variable is. So it's not a math class variable. And math class variable means the unknown, the thing we don't know, right? But in a programming setting, we know exactly what variables are. So I'm gonna draw this picture here called a stack heap diagram. These are very common ways to represent what's going on inside the machine. So a stack is like a stack of plates. We're gonna stack a bunch of things off, and then we're gonna take the top one, then take the next one, and take things off one at a time. That's our code. So the instructions we write just get stacked up for the computer to run when it's ready to run. And then heap is a very dynamic structure. It changes stuff. It gets a little complicated. It's a very special kind of tree. I'm using the correct terminology and stuff, but as far as these pictures, that represents RAM. It's the very best way we can organize data in the computer. So that's what we go ahead and take the time to do on the RAM chip. So in our instructions, we said H equals something. So I created this variable. And all the variables start with a $sign. Notice I keep saying H, not $H. I'll be doing that all night. So you get so used to it, we just ignore that part. That's just part of the syntax. It means we have a variable. We needed to store some data. So we did that get host data, and then we have a bunch of binary code over in RAM somewhere, right? Like 10011100101. Yeah, all of that stuff I just made up the ones and zeros. I don't know what the particular return would exactly be. I saw the text version of it, but that's stored in RAM, and the computer knows where it's at because maybe the computer knows that starts at bit. I'm going to make something up. 319,402. And is 398 bits long. That's how the computer remembers where that data is. But as a human, I'm never going to remember that. I just wrote it on the board and turned around and I already forgot the numbers I wrote. I made them up, but I'm never going to remember that in order to work with it. I need something useful. So it's like your neighborhood. I was thinking of the neighborhood analogy. If you're talking to your neighbors, you can give different directions than you would to an outsider. Talking to your neighbors, you'd say things like the Joneses' house, the place that used to have green shutters. If somebody's driving through from California and they're lost, telling them, oh, it's next door to the Joneses' house would be completely meaningless, right? Or the house that used to have green shutters is beyond useless because they're not even that color anymore. So it's the difference between talking to insiders and talking to outsiders. Here's the inside version. The computer knows this, the word outsider will never keep track of that. So a variable is just a named location in memory so that we can keep track of it. And then there's just a pointer going to that spot in memory. And computers are great at keeping track of that, so the computer keeps track of both of them for us. That's what a variable is. So it stores that so we can reuse it. It's not math class. We definitely know what our variables are. If there's ever a time when you don't know what's in your variable, that's a problem. But then we can do stuff with it. So now I can ask to print that out. So I'll write it the whole way, right? Dash host $H. Oh, it just said what it is. All right, $H. Okay. I guess I didn't need to write it. Told me what type of thing it was when I said write host. But notice that naming convention again. Host is the terminal, and then there's some keywords dash that thing we're working with.
So you have to use the $sign to make an abbreviation like that, like a saved command.
To make a variable, yes. Yes.
And also tell me how long it takes to run the command when I saved it.
It's probably in there somewhere. But there's more than just text here, right? To spit out that text. You can dig through and get it. Mine's just abbreviated in local. It's under local run space, so I could say $H. And then all of this stuff are things we can access. So I can say like dot which one goes further? Dot UI, I think goes further. UI. And when I get that, I see that, and notice there's two more things there. So $H dot UI dot supports virtual terminal, because this is one that will be very important. So notice I can access each one of those things going down the chain. I don't have to just retype that text in myself. It is something different. It means something different to the computer, and the text is a byproduct of what it means. That was one of the big things with PowerShell. That was one of the big reasons Mac and Linux gave up their plans. And Windows kept the old commands. They were just going to do away with the old commands, but PowerShell kept the old ones too, so we can use the old ones if you know them. Instead of set location like we did earlier, we could still use CD. Or to list out the stuff in the directory. Traditionally on Windows, it was dir. So this is still kind of preview mode, so we can access all of that stuff. Supports virtual terminal is important. That means that we can do SSH. So I don't need secondary software to access an AWS server. SSH is built in here already. So that's one you probably want to make sure is set to true. If not, you would reassign that. So $h.ui.supports virtual terminal equals true. And the equal sign is going to be, we read that as a sign equal to equality, or is in normal English, uses a different symbol. So when there's one equal sign, that means assignment. So this word we made up, or this letter we made up, is assigned this get host value. So that's part of writing software. We can see all the stuff in there. And then like old commands, dir was Windows' way of listing out the folder set. ls was Linux's way of listing out folders. And you can see it works. Both of them work. Get child item. Let me write that differently. I'll add some capital letters. Get child item. The words PowerShell built into PowerShell are not case sensitive. So uppercase, lowercase doesn't matter, whatever's convenient. But the words you make up are case sensitive. So like there's a folder there called Model 1 with a capital M. If I tried to write that with a lowercase m, it wouldn't find it. So it knows its own stuff without the case.
So my dir and ls gave me two different things.
Yes, so dir gave you this.
They gave me a nice list that looks different from that. And then ls gave them all, but they're all just next to each other loosely. It was no like.
Okay, so on the Linux one, it's pulling from the system.
Yeah, so dir gives you a nice list with data, and then ls just tells you everything, and it has no organization in it. It's just all loose.
Oh, you want ls-l.
No.
So the old Linux commands still work. But yes, so notice we can mix and match our commands from the different systems.
Not recognized.
Oh, it doesn't recognize -l?
Nope.
That's odd. Get child item is the new one, because as far as folders and files in the folder, or folders and folders inside that folder, directory would be our correct term, but sometimes folder fits better in a sentence. We speak English, right? There's lots of synonyms. The directory and then other directories and files inside those directories are considered parent-child relationships. So a folder inside another folder is a child of that folder it's inside of. So to get those, they're child items. So we can say get child item. And that would be the modern syntax, the non-abbreviated way to do it. And notice that nice naming convention. Child items is useful. Maybe remove dash child item. And I want to remove project.simp.user. That's a backup file. Oh, case sensitive. That's not a built-in command for PowerShell, so it's not going to let me remove it. Any quote marks on that?
Do parentheses mean something in PowerShell?
I think they do.
Also, if the LSS or LSL, whatever, it worked, I just had to put a space.
Let me try and remove that other folder. So, oh, yes, sorry. Things are space delimited. So anytime we put a keyword and then want to do something else, put a space between them. So if you have like spaces in your folder names, file names, make sure you put quotation marks around it. Which means that the space is just another letter to the computer, it's just another symbol. It doesn't know the difference between the space and the letter R. They're just symbols that humans use. So if we want it to be explicitly a space and not separating things in our terminal, make sure you put quotation marks around it. So let me get child item again so I can see what's here. That's from some high-end software. So those files are probably locked. I don't know why it's not letting me delete those. Let me try this again. Remove child item model 1. I have to type this word. Okay, I'm currently getting an issue there. So there's also built-in help functionality. This is the most useful one. So get-help. Let me see what get-help on remove is. It'll go look for stuff. And then one of the most important things here is learning how to read the instructions. Remove item. I was trying to do child item, but we don't necessarily have to be in the same folder. We can remove something from somewhere else on the computer. We could remove the folder we're inside of. That would cause problems. Don't ever remove the folder you're inside of on purpose. But it's remove item, not remove child item. So make clear host. A clear host would be the modern way to do it. The old Linux version of clear works, or the old Windows one of CLS for clear screen works. So the old commands work, the new commands work. Makes PowerShell a really nice terminal to work in. You can mix and match them too. We don't have to choose one. We have those naming conventions, so we want to get something, in particular get help. Whoops. We want to get help on that remove item thing. So I apparently couldn't remember the name, so I put get help remove, because I knew that was part of it. It's definitely wanted to remove something, and it spit out a list of everything that had remove, every instruction had remove in it. So now I can put this get help, in particular get help space remove item, and that will tell me exactly how to remove an item. So there's the old commands, RI for remove item, RM for remove, the old Linux remove, bash, actually bash. Those aren't Linux, but we pretty much only use bash on Linux anymore. So if I say those interchangeably, technically those belong to a language called bash, and we just only use that on Linux. DEL is delete, that's the old Windows command. So you notice there's more than just the old Windows and Linux commands. Erase, RD, and then right above it is showing the new thing. So how to read these instructions is very important. So there's the one we want to run, and it does allow overloading. So overloading means we make multiple functions with the same name, but we give them different parameters, and then the computer will figure out which one we want based off which parameters we pass in. I'll look at the first one. So remove item, and then notice space, and the first thing, this is called a parameter, and then we'll send an argument to fill that parameter. The parameters are where they're space delimited. So the first parameter is path written in square brackets. And then after the square brackets, we see string written inside of angle brackets. So string is the type of data. So that's saying there's a path parameter that needs to accept some sort of string. Basically, what do you want to delete? Hopefully that makes sense, right? The file path to the thing we want to delete, starting at the current location. And notice that here on that first one, string is outside of the square brackets, but on the next parameter, then we could pass in a filter, and here string is inside of the square brackets. So if the type is outside of the square brackets, then it's required. We cannot run a remove item command without the file path to the thing we want to remove. Hopefully that makes a lot of sense, right? But if we wanted to do some filtering, like search what's in that file and make sure that's what we want to delete before deleting it, that's optional. We don't have to do that part. So the type is included inside of there. And then down here later, there's like confirm. in square brackets, and following that is another thing in square brackets. It doesn't even have a type there. If there's no type put, it's a Boolean. That's the data, that's our true false values. Our one or the other, it's named after George Boole, and Boolean algebra is the mathematics in the binary, all the math that we do with binary states, and we're in binary state machines. So that's our primary thing. That's true false. So if we leave off a Boolean parameter, it's false. And if we want it to be true, we just write the parameter on it. So omit it for false, write it in for true. And that's consistent on all terminals, going back all of our terminals. If your other ones, when they're all abbreviated, if there's a Boolean parameter, you just write it in there to make it true, or omit it if it's false. And that's how to read those instructions. So all the help in this thing will tell you how to work with it. For Windows users, we have something nicer to look at afterwards as far as help doing that. Here's that sort of the general syntax. We saw the get dash help. That's the important one. Get help, and then it will start looking for words. And it's 2023, so if it doesn't find it on the local machine, it'll try to search online. By default, you're just probably going to ask for. It may not have permission to search online by default, but at some point it will probably ask you if you want it to continue the search online. And once you give permission, then it'll just start doing that if it can't find it locally. So get help's an important one. But let's talk about some of the instructions we can run. Look at variables. In this case, it was just something about the terminal. At least for starting in programming, we think of smaller things like doing math with numbers, right? So to do math, we probably want to store it in a variable. That way we can keep track of it a lot easier. In math class, we'd always do things like X, right? Say like X equals 3. But don't be lazy with typing. Way back in the day, everything was abbreviated, and there's still some remnants of that we'll see around, but typing's easy. And we don't have to be conservative with our RAM chips anymore. We have lots and lots of RAM available. Everybody here tonight wrote about your computers in the hardware system, and all of y'all have some pretty nice computers you wrote about. You'll have lots and lots of RAM, so don't abbreviate your variable names. Do something meaningful. So like first number. Your restrictions are no spaces. It has to start with a letter. It must start with a letter. Well, in PowerShell, it must start with a $sign. And immediately after the $sign has to be a letter. No special characters, no numbers. A letter first, but then after that first letter, you can throw in numbers. So we could have number 1. That would be an acceptable one. You could say number 1, and then follow it up with number 2. I'm going to do first number equals 3, and that's a much better way to keep that around. It has meaning. We use variables so that we can remember what they are. So if they have a useful meaning, we want to put it in there. There are some other things we can include certain special characters, but for starting out, it's probably easiest just to say no special characters. It has to start with the $sign, then afterwards, then the first symbol has to be a letter, and then after that, only letters and numbers. And come up with some meaningful name to hold stuff in. So like our second number is 4. And then we can do some math with that. So we could say, result is assigned whatever value we get from first number minus the second number. And then we can print out result. Get a -1 for that. Or I'm going to abbreviate, accelerate this a little. So first number, an asterisk is used for multiplication. And I'm actually a math person, and over in math, we call that a star. We call that star because it's a lot easier to say, and they show up all the time. The plural is a lot easier too. What's the plural of asterisk? Nobody really knows that. But that symbol shows up all the time in America. It seems like somebody should know that. So if you hear me say star, I'm referring to the asterisks. So first, we can multiply them, we can divide them. First number / for division, the second number. And that gives us the floating point division. I'll just jump ahead because y'all are used to calculators, right? You grew up with calculators, you use floating point division. We also have quotient and remainders. And quotient you can just grab from the floating point division. Most people under the age of about 30 are more comfortable with just grabbing the integer portion from the floating point than having two different division operators. It just makes more sense having used calculators your entire life. I think that's why. So I'm just going to show that one. But we also have the remainder we want to do separate, right? So like instead of 0.75, we want to do 3 divided by 4. Oh, I should go the other way. 4 divided by 3 gives us what remainder? And we use the percent sign for that. It's called modulus. So second number mod first number will be 4 divided by 3. Yeah. 4 divided by 3 leaves us a remainder of 1. There's some very useful things for that. They'll probably show up later. That might seem odd at first, but there's a lot of uses for that. So like a vending machine, to give the proper change, coins, they only use modulus, not subtraction. That's a fun little exercise to think it through. But there's a nice little math trick that we can always, the remainders are enough to work on. Back in the day, it was a lot more useful. So if we had, say, 18 plus 7 gives us 25, right? But if we did all of that modulus 4, means we're going to divide by 4 and use only the remainder. So 18 divided by 4, 16 with 2 left over. So yeah, 2, 7 divided by 4, we go 1 time, 3 left over, plus 3, and 25 divided by 4, 5 with a remainder of 1. So 2 plus 3 equals 1, but we're doing this mod 4. So 5 mod 4, 2 plus 3 is normally 5, as we know it, right? But we're only going as high as 4. So if we divide everything by 4, our only possible remainders are 0, 1, 2, 3, 4, and 5. So 5 is too high of a number, so we divide that by 4 again, and we get 1 with a remainder of 1. So we can work solely with the remainders and get the same result. And then at that point, we could turn it back into the earlier one, if we kept track of stuff along the way. A useful little, it used to be incredibly useful and important for like astronomical calculations back in the 17 and 1800s. Like you had big numbers with great big huge numbers, and you had to work them out by with pen and paper. So being able to do it like mod 12, and then you only have the numbers 0 through 11 to work with. It's a lot easier to not make a mistake in your calculation, and then turn it back into a big number afterwards. So it's useful that it has lots of uses. So a secondary division thing, we just use, so the percent sign gives us the remainder when we divide. Subtract, adding's obvious. The addition sign can also be used for concatenation. That means put words together. So let me store a couple words. So like H is assigned the word hello. And W is assigned the word world. And then I can put those together with the plus sign. Obviously, plus sign also does addition. Probably don't really need an example of that, right? So H plus a space, because a space is just another symbol that the computer has no idea what a space is. It's emptiness to a human, but not to a machine. So you always want to include that. $W, and then it puts those words together. That's called concatenation. Anytime you're working in a programming language that starts with a $sign, that's how you spot the loosely typed languages where we don't have different data types. We only have one type of data. It's usually called resource. Concatenation is also a step easier because concatenation is automated. So if I wanted to put that in a string, I could just open quote marks and say, put that variable there, then a space, then the other variable, and close the quotation marks. So just by throwing those variables in there, it concatenates the words together. We have a couple ways to do it. So we can do some basic math, store some words, get back to those words we stored, other information about that. That's sort of what the software stuff is. But really, software development is about problem solving. We do this in order to solve problems. Did your laptop die on you?
Yeah.
You can slide one of those desks over if you want to sit close to the charger. They're not bolted down or anything. So problem solving, that's what software development's really about. And there's an interesting thing about problem solving. Problem solving only requires 4 types of tools. Which our technical term, when we dive into it deeply, are known as our 4 constructs. And like all tools, they can be put together in different orders and used in different fashions and need a little bit of adjustment for every particular use, but there's only 4 types of tools needed to solve any problem. First off, we need some sort of sequence to flow through, some sort of order. So a sequential tool. And programming languages, that flows naturally because the sequence is the order we pass the instructions in. So we can't put together a programming language without having a sequence to it. So the first type of tool is met. The second type of tool that's required would be some sort of selection tool, a way to make choices along the way. That way variance happens. Things alter. We do something different at 10 in the morning than we do at 10 at night. So we check the clock and react differently at the different time of day. Or getting dressed every day. Right? Wake up in the morning, start to get dressed, and some choices need made. If it's cold, we put on a sweater. If it's hot, you don't grab a sweater. So we need to make choices to solve the problems. That's a very important part. Some sort of selection tool. We have that in there. We'll see that in a minute. Computers are great at deciding between binary alternatives. If we have binary options, that's the greatest things computers can do. It's actually more than one way, but it get advanced. The only thing computers do better than that is throw errors when things go wrong. So if we know that's going to happen, we can actually use that throwing errors as a quicker way to make the choice. If we're looking for a file, make sure a file exists. In order to confirm that the file exists, we need basically all the bits in the file, right? We have to look and make sure every byte that file is supposed to have is stored there and we can get to it. But for it to not exist, we only need the first bit. And we can say for certain it doesn't exist of 1 bit. And that makes for much, much quicker selection. So we can get very refined, but we have a nice, easy way to do it today. That's getting into advanced stuff. We When solving problems, we might have to carry out some steps repeatedly. Removing screws, right? A couple weeks ago in the hardware stuff, there's a bunch of screws to take out. We don't turn the screwdriver once and then the machine falls apart. We have to repeatedly turn that screwdriver until the screw is all the way out. So some sort of reiteration. And I always use these words very carefully in class. I'm going to write both of them, reiteration or repetition. Whenever I'm talking about them, and regularly do software development, repetition is exactly the same thing over and over and over again, no variance. And I use reiteration for repetition with variance. So a great example is mowing your yard, right? Everybody's mowed a yard before, I assume. You get out there, you get your lawnmower, you push it down and mow the strip. So repetition would be, you go back to the beginning and push the lawnmower down that strip. Go back to the beginning and push that lawnmower back to the strip, and you will never finish mowing your yard that way, right? We need variance. So we push the lawnmower down the strip, and then we vary it. We turn around and move over and push it down to get the next strip. So that repetition with variance is reiteration. That's an important thing. But sometimes we don't vary it. So a great example is like a little animation on your website. Whenever somebody goes to your website, you want the animation to start moving, and you want that animation to keep looping until the person leaves your website. There's no variance. So the variance isn't necessarily required. So either one of those would work somewhere in the 4 constructs. And the fourth one, since we're talking about computers, I'm going to use the word invocation. There's different ways we can say it. We need an invocation tool. What that means is we need a way to jump out of our sequence, do some other stuff, and come back to our sequence. So we're going through like step 1, step 2, step 3. Oh, wait, I need to go get ready for the upcoming one. I have to jump all the way to step 20, do steps 20 through 25, and then come back and do step 4 or step 5. So we have to have a way to jump out of our sequence and back in. Software development is about problem solving. So obviously we need these 4 constructs, but that's not a computer thing. That's any problem. You're hanging out with your friends, watching something on TV, one of the free streaming services. I'm very cheap, so I tend to watch Tubi. I didn't pay for ones, so get interrupted with commercials. But you hit a commercial break, or maybe traditional TV or something. The commercial break comes on, you jump up and go to the kitchen to get everybody drinks. That's a problem that needs solved. So there's an order, right? You go to the kitchen, get out some glasses, you put some ice in some of the, you got to make choices. Some of the glasses get ice. Some of your friends might not want ice, so some of them don't get ice. And then what goes in the drink? Right? Water for some people, Coke for some other people. Make choices about what's in there. You repeat it get a drink for everybody that's in the other room waiting on you to bring them back. And somebody yells in from the other room. It's like, oh wait, never mind. I don't want water. Bring me a Coke because I'm about to fall asleep and need the caffeine or something, right? And so we have to jump out of our sequence, make any adjustments, and come back into our sequence right where we left off for that change. Those tools apply to any problem solving. The famous one, world peace. It will only require these 4 types of tools. It's just nobody's figured out the right order and choices to make along the way in order to do that. And then which of those choices to repeat until it works. So that's what's needed to solve problems. And we have all of those tools in a programming language. And Powershell is a modern scripting language. It'll take about 15 minutes to go over all of this. We are definitely in preview mode tonight. And might take a little more than 15 minutes. So now seems like a good break. And then we'll look at the scripting parts of this, how we do things with that. And then I have some other things we could look at, other useful things, modern scripting languages, or more things in a terminal that will be useful to go. If it's been about an hour, does 10 minutes sound good? All right, my laptop says 7:01, so we'll get back to it at 7:11. Stop this recording. I'll run down to my office and grab my coffee.